All right, so if you can all hear me fine, everyone's good, has their tea and biscuit, and I don't know what British people have for lunch, obviously. Then I'll begin today with, a case study, a story that I want to tell. So thanks everyone for coming during your lunch break. I will discuss, as I said, this case study, which is based on maybe two and a half of my clients, I'd say. I won't name any names. I think some of the things that I'll be talking about will sound familiar to a lot of you. If not, I hope you have a vivid imagination and you can then, infer from context, hopefully. So first things first, who am I and what kind of clients am I talking about? My name is Lian Li. I'm an engineering manager with Container Solutions. We are a consultancy focused on programmable infrastructure and cloud native transformation. As an engineering manager, half of my time goes to line managing, and the other half I am a consultant on projects. So I help customers directly, hands-on. And I've been in tech for about a decade now. I started as a backend developer. I moved to front end, then I did some full stack, then I moved to DevOps. Then I dabbled in data engineering for a year. And about 3.5 years ago, I moved to Amsterdam to join Container Solutions. So the clients that I'm speaking about are mainly huge enterprises that I've worked with since I joined CS. Before that, I worked in mostly like mid-sized organizations. One was bigger, was a gaming company with around 800 people. So I've seen quite different ways that people approach these issues of delivering software. But what's most interesting, I think, for today is to talk about this kind of amalgamation of clients that are huge enterprises in highly regulated sectors. So so this fictitious client that I'm going to be talking about is acting as a stand-in for the problems I've encountered at these types of organizations and how we solve them. Okay. So this client that doesn't exist is called MoneyBank. So you might be able to guess what kind of sector it operates in. It is a huge enterprise with a tech department of around 200 engineers. That would include software engineering, operations, and even office IT. As it is also typical with enterprises, there are clear hierarchies and to some extent clear roles and responsibilities. I say to some extent because these roles and responsibilities are not always clear to everyone. There's a C-level, there are multiple layers of middle management. You probably know how that usually looks like in these types of organizations. And finally, as you probably have guessed, since MoneyBank is operating in fintech, you probably also can guess that they have very strict regulations. And this sector, fintech, is a sector that we've seen really explode in the past couple of years. So they've been looking for ways to streamline, the way that they deliver software in these highly regulated environments. So within the engineering departments, and now I'm excluding office IT, office administration from that, we have product teams. So they develop individual products and features. For example, the software that's used by bank tellers or the online banking software used by clients. There are service teams, which provide internal services for the product teams. For example, most notably, this would be operations because they provide the service and platforms that the products then run on. And finally, we have specialized teams. They act as facilitators and internal consultants, but they don't directly contribute to the product pipeline. So an example for that would be the security team, which provides best practices and guidelines to the developers, but they don't really, develop anything for the product. So if you've read team topologies, that might be similar. This might sound familiar to you because they have this the same kind of structure in which they split up the teams. They just name it differently. There's one team that is kind of not really inside the structure. That's the team that's QA. So QA is somewhere in between a service team and a specialized team, because on one hand, they provide developers with an assurance of quality, so kind of like QA as a service, but then they also develop best practices, which they then share with all the developers, like the security team. So QA is somewhat kind of in between. So when we first met with MoneyBank, their biggest challenge was that their delivery was slow, and they already identified that it was because a lot of the steps were manual. So I already mentioned QA, and that they're somewhat of a service team, somewhat of a specialized team. And the consequences of the structure was that QA was a complete black box to anyone outside. They had their own way of doing things. They were completely independent, which then meant that the handovers to and from QA were often kind of laborious and had to be done manually. The other thing was spinning up of test environments for QA, which also had to be done manually, or at least there were some scripts, and those scripts had to be modified and then triggered manually. And by the way, this was not just a test environment, it to some extent also applied to the staging environment, because that also required some manual work to get ready, to load test data, for example, and so on. And finally, because of compliance reasons, there was always a final check by all major stakeholders, and that final check was always manual. So yeah, that was also slowing down the entire pipeline immensely. So after we spoke to them and we felt like we have a basic understanding of their problems, we started, throwing in some suggestions, discussing them, and then basically we came to this conclusion that this would be our proposal for them. So for QA, we figured that, there's no other way to get around reducing cognitive load and workload for the handovers. And we figured the best way is to get the QA to automate all the tests, which would also help us understanding what they're actually testing for. To quickly spin up test environments, we suggested to move to container orchestration, something like Kubernetes. Before that, they were on Docker Swarm mainly. I think some were running on Mesosphere, and they all were also applications that were completely not containerized. They were just running directly on Tomcat servers. In this case, they chose to host their own OpenShift clusters in-house because they wanted to guarantee that all data and traffic was kept on-premise. And, they're a huge org, so they have the budget to hire like a company like Red Hat. And finally, to ease auditing and give everyone kind of the security blanket that they need, we suggested to go with GitOps as a flavor of CICD. So luckily, we came to an agreement with them. They liked our proposal, and we were hired to help them move their services to this new OpenShift GitOps platform that we helped them build. So I don't know what the level here is, but I just want to walk you really quickly about what GitOps actually is, so we're all on the same page here. Basically, and I know that there are differing definitions for that now, but basically in GitOps, you have a Git repository in which you store the configuration of your infrastructure. This could be Kubernetes manifest, Helm chart, Docker Compose, YAML. It doesn't necessarily have to be Kubernetes. Like GitOps also works without Kubernetes. Having a repository like this comes with a lot of perks, like you will have an audit trail. You can collaborate on integration with features like a pull request if you're using a Git provider that has that feature. And this repository then is connected, synced to an environment in which your application lives. This can be your Kubernetes cluster, it can be a VM, it can be something like ECS. So again, it is not dependent on Kubernetes or even containers. It is just this general pattern practice. Then you'll need something that facilitates the deployment of the environment. And in this case, you can use, for example, the Kubernetes API. So the idea is that you declare the state that you wish to have in your environment, in your config repository, and you tell something, please make this happen. In this case, would be the Kubernetes API. So this is the very general, broad explanation of what GitOps actually is. Right, so to understand the changes that needed to be made, let's consider the starting position first. So this is how the release process looked like when we first spoke to MoneyBank. A release or change would always start with the product owner requesting a new feature. They would speak directly to the devs or open a ticket in the ticketing system. That was kind of depending on how they worked. The devs would then pick up that request, implement it, and do some local rudimentary testing. Some services had unit tests and some didn't. Next, the devs would merge or cherry pick all the changes into one release branch. So now we have a release package on that branch. Now there's a role that's called the release manager. It's the third lane. And this is a specific role that is sometimes taken over by the dev team lead or the PO. So it's usually not its own person that only does release management. And this release manager will then build the artifacts. They will deploy them to the development environment. And the devs can then do some integration tests between the services. And then when they were happy, they could approve the changes. Now the release manager would inform QA. And QA would deploy the changes to a test environment and run their tests and approve the changes. Once again, we didn't know how they were doing it because there was kind of like all a black box and we didn't have any reach into the QA team. So once QA was done with that, they would then inform the release manager again, who now triggers the deployment to the staging environment. Now, when that is done, the release manager informs the PO, the product owner, to do their own test and then give final approval. When that is done, the entire change log, including all the references to commit hashes, artifacts, everything, are bundled up and sent to the operations team. So they can do like a final check and approval and then deploy the changes to production. Sometimes things go wrong here because despite all the rigorous testing and everything, production staging and test just fundamentally differed from each other because of the way they were maintained and provisioned, mainly because of convenience, because it was such a hassle to spin up the environments that people would just be like taking shortcuts left and right that they wouldn't take on production, obviously. And now things that were tested in very rigorously on staging just didn't work the same way in production. So the first thing we did was we took a look at this middle lane, the things that the release manager were doing. There's some stuff here that's bluish, greenish, and these are things that are automated in itself, but require some manual triggering. So there's a script or something that will already do that, but you have to like still click a button. The test and approval step here is somewhat automated for some services. As I said, some services had unit tests, so you could just run those unit tests. Some services also had integration tests, others didn't. So you could never rely on the fact that everything's automated here. And the same goes for the deployment to staging. So I said that there's some manual work involved for the staging environment. And the reason why is because it's a shared environment. And the release manager can use an automated process to deploy, but then they still need to go and like do some legwork, update some configuration here and there to say, okay, this is like now called a new version of this application instead of the old one. So just to make sure that all services are still talking to each other, there's always some manual work involved. So what we first try to do is to automate the role of the release manager and have that taken over completely by the system. Just seemed like the lowest hanging fruit. So in this process, we would start again with the PO requesting a feature, with the devs implementing and testing. And now any merge to the release branch will trigger a build step. So any merge to the release branch triggers a build step. Build a Docker container. This also, but then it meant also that cherry picking was very much discouraged to keep the tree clean. And once the build was done, a deployment to the development environment would now be automatically triggered through the magic of GitOps. So the way that it worked was we would create a pull request to our config repository, and that would now automatically be merged. The pull request is auto-merged by our pipeline engine, and then we run our automated tests. So obviously, that means that only applications who have automated tests can go through this process. So this was a way that we enforced, teams writing more unit tests and integration tests. If all tests passed, QA would be automatically notified that a new release was ready to be tested. They would take over, go with the usual flow, deploying, testing, approving. And then to give their approval, all they had to do now was to approve a pull request that had already been automatically created. So we create this pull request on a merge to the release branch, as I said, for dev. At the same time, we also create the same pull request already for staging. And QA doesn't need to talk to anyone anymore. They can just approve the pull request and then approve and merge it. And that would then trigger the deployment to staging automatically. And once the deployment to staging was done, the product owner would now receive an automatic notification that the changes have been deployed on staging and are now ready to be tested. And the rest of the process stays the same. So what's great about this is that we already, that by the time that we implemented this was that we managed to abstract the infrastructure already in such a way that automated deployments through the GitOps platform were technically possible everywhere. But within this process, some of the deployments were still done manually. So like the one to prod and the one to test. That's what we're going to focus on next. But first, I want to show you the architecture that we built. So everything starts with the application repository where the source code is. You can find the source code in it. From there, we used a Jenkins pipeline. And the Jenkins pipeline will do two things. I technically will do a bit more than two things, but let's keep it simple here. It will first build the artifacts and push them to an artifact repository. So here we use SonarQube Nexus. It was a completely Java-driven organization, so they already used SonarQube to the Nexus to store their jar files and everything, and that would live outside of our Kubernetes clusters. After all the artifacts were in place, were published, we would then submit a change to the config repository, starting with a dev environment. So we created one repository for each environment and for each namespace, which was a business unit. So if you had multiple services in the same namespace, then they would all be living in the same config repository. Now this repository would trigger an Argo CD instance to deploy the resources. And we did this again for each cluster. So each cluster had its own Argo CD instance. Argo CD would keep monitoring the repository and deploy automatically if any changes were detected on the main branch of the repository. So this is where, eventual consistency comes into play, which is also important for GitOps, that when you fire up the, when you make the commit to the config repository, you kind of have to rely that eventually this will become the state of the cluster. But GitOps itself does not guarantee that you will definitely have that state at any given time. It's just an eventual consistency. And technically, this would work, as I said, for all environments until production, but we're not quite there yet in the process. So the actual setup is a bit more complex than this, but hopefully this gives you a general idea of how the flow kind of looked like. So back to our process here. When we take a look again at this delivery flow, what we can see is that the deployment to prod, for example, is still being done manually by the ops team. And the reason why it was done manually here still was because they were the owners of the most sacred place, the prod environment. So they were personally responsible for what happened there. And I mean personally, not by their role, but as their person. So they were complaining, for example, as a joke, I hope, that you have to sign everything 3 times in blood before it can go out to production. That's, of course, it doesn't really scale that nicely. So what we did to address this was we, again, automatically created a pull request with the changes between prod and test or prod and staging. And the ops team simply needed to approve that pull request through the magic of Git or GitHub or whatever you're using. In this case, by the way, we use Bitbucket. So they only need to approve and merge the pull request, And that would trigger the automated deployment through Argo CD, the same way as it worked for dev and staging. And this already took a lot of time and responsibility off their plate because they didn't have to do the actual deployment. And interestingly enough, we detected less errors in prod after that instead of more, which was always management's biggest concern. But it kind of proved us right that it was really a lot of cognitive load that made it hard for ops to really keep on top of the deployment procedure. Obviously, they had their own documentation and everything, but it wasn't standardized, and that's why things went wrong sometimes. So after we've done this, the next step was to take a look at the QA. So I already talked about it. The QA had their own development culture, their own structure, own way of doing things, and that tended to cause a lot of friction between the product teams and QA, because it was always like, this is the bottleneck. We don't know what they're doing. We don't even know what they're testing for. So we can't really optimize for that when we build the software. And QA didn't belong in the normal structures that we have. So we discussed this a lot of times, and then we came up with like a bunch of different ways to address this. Finally, we figured that the only ideal solution is a truly radical solution, which is to eliminate QA completely as a team and as a lane in this process. And they went for it because they hired us for truly radical change. So how would this new process without QA work? Obviously, I'm not suggesting to eliminate quality assurance, still need to do that. But instead of having it as a separate team and swim lane, instead, the suggestion was to embed QA into the development team so the teams were truly cross-functional. And the team member that is responsible for QA would write the test suites already during implementation, but still keep in touch with the other QAs through a community of practice. And this way, everything became instantly more transparent for all the teams, and we could standardize. So in this process, everything stays the same up until the devs are done with their preliminary tests on the development environment. And now the test environment fully belonged to the dev teams. So they were finally able to do away with all the extra stuff we needed to do for QA. Instead, QA and the dev team collaborated on the test environment instead of QA owning them and devs just not being able to do anything on it. So again, it was a huge win that we could now standardize over practically all the environments. And again, that would reduce a lot of the cognitive load that the developers had to kind of carry around. So the tests were run and improved automatically, more or less, but it wasn't that bad now because everything happened within the development team. So there was no dependency to an outside team where you have to wait for a week or so. So once the test and approval on the test environment were done, we would then deploy to staging automatically because now everything's automated. So we can then just create and merge that pull request to staging, and we would then send a message to the product owner again, and the rest is the same as we already discussed. So everything's great. At this point, we were with MoneyBank for a bit over a year, maybe 1.5. Development speed did pick up a lot. Developers were much more productive now, at least they felt more productive now, because they could focus on the development instead of merging strategies and remembering to get their features out on the right day at the right time. And everyone could deploy at any time, and they did a lot. The confidence in the CICD also grew, because if you use something twice a day and it only breaks, every 4 months or so, then it's quite, I don't know, confidence. I'm looking for the word. People had a bit more confidence because they used it so often and broke so little, as opposed to before, where they were using it seldomly and it would break almost every other time. But the thing was that there was still one issue that was bugging the engineers, and they had kind of united now and picked the new person or the new thing to blame, which was the slow deployment to prod. So what I mean by that is, when we take a look here at the process, you can see that there's a lot of stuff automated in the blue lane, but there's still this last thing right before we go to prod that is manual, because the PO needs to step in, do the test and approval, and the ops team needs to do the approval, plus the stuff that happens in the beginning that's also manual. So there's some things like these red things that will probably never be automated. They're by their nature, in their nature, they are manual tasks, at least for now, at least before the robot uprising, before Google GitHub Copilot takes over for all of us. But if you look at these other steps here, I think there was something that we could still do about it. One of the main reasons why the PO and the ops team still needed to do manual approvals is because they needed to sync with the board and other higher level stakeholders about business intentions and business implications. For example, do we maybe need to communicate a downtime? Should we send out a press release about a new feature coming out? What are the risks when we deploy this? Do we maybe need to prepare for like a total failure of the entire system? Is that a risk? So on the surface, these are also kind of manual steps. At least they feel like they're in the nature manual steps, but we still felt that there was something we can optimize about this. So in one of our sprint reviews, we had a stakeholder who was quite critical, but in a good way. And he always kept pointing out, a pull request is just not enough. Business people cannot read that. They cannot just look in a pull request and go like, oh, you increase the replica count here. So I understand now what that means. They don't know what that means. So I was like joking and saying like, oh, but they can read Jira tickets, right? So then we were like having this moment of like, oh, are you thinking what I'm thinking? And we were kind of coming up with this pattern, which I'm sure that other smarter people have come up with way before us. But the good thing is that I also introduced a catchy, salesy name, so we can now go out and sell it. So yes, the idea of ReleaseOps was born. And again, it's probably not a new idea. The basis of this is that we wanted to align what a release means for the business with what a release means for our GitOps platform. So I moved some of the swim lanes around a bit now to illustrate better without the arrows going all over the place. There's a second blue line now, and that is our newly introduced shiny ReleaseOps automation layer. And in this case, all it does is it represents the state of a Jira issue. So what we do here now, we start again with the PO requesting a feature, but this time they don't message the devs about it. They create a Jira issue outlining the feature request, acceptance criteria, and the release now gets an identifiable ID. The devs are automatically informed. They implement the request. When they make design decisions, they comment in that issue, explaining their reasoning. And when they are done, they move the issue to the next status, which is in deployment. So now, once we move that into the next status, this automatically merges their feature branch, their release branch into the main branch, or the feature branch into the main branch. So we're already now abandoned Git flow, and we're using trunk-based deployments now. So we achieved this only by allowing the development branches to have been created through the issue. So because they have to be linked, so we can have this automated changing of the issue state will then do something on Git. And I already said that we're using Bitbucket and we're using Jira, and some people are like moaning about it, and I totally understand why. But Atlassian delivers solid products and they integrate very well with each other, so why not use it? It's not like we're doing super fancy stuff anyway. So from there, we can now go to the below swim lane. So we're merging into the main branch, and immediately automation takes over. We do everything that we talked about before, deploy to staging. And now we can instead of talking to the PO we will now set the ticket to in review. Now, when it's in review, we will ping and assign the ticket to the PO. And we could only achieve that by having a mapping of the PO and the services on the cluster. So we still need to do some like configuration stuff here and there. And the PO now knows, okay, cool, it's on staging. Now I'm going to test it. I'm going to give my approval in the ticket. At the same time, the ops team, they are always triggered when an issue goes to review. And the ops team, they're the owners of the last column, the approved column. So they're the only ones who they will test, and then they will move the ticket to approved. And they're the only ones who are allowed to do that, because once that ticket is approved, we will automatically deploy to production. So again, the ops team are the last gatekeepers. But in this case, now all the information that we have ever had are in this ticket. So we don't have to send emails around and all of that. And we can hand this ticket over to our high-level stakeholders, to marketing, to sales, and let them know, look, there's all the information you need to know right here in this ticket, including business implications and so on. So this is what the design of this architecture would look like. So now everything starts with a Jira issue, which is tied to the application repository through a Jira Bitbucket integration. Once we merge that feature branch into the main branch, we have a pipeline that, similarly to the pipeline we looked at before, will first build and store artifacts into the artifact repository. And at this time, we now have split out a cluster that's specifically to manage the CICD and other clusters. So on this cluster now, we have an Argo CD that manages the other Argo CDs. It's kind of like an apps of apps approach. We have these, we have all kinds of stuff that's in here that manages other clusters. I'm not going to go too deep into this because I could give another talk just on that. And we replaced Jenkins as the pipeline engine with Tecton CD, which by this time has already been integrated into OpenShift 4 and is called OpenShift Pipelines now here. You can still get Tecton outside of OpenShift, but if you want it in OpenShift 4 and later, it's OpenShift Pipelines. Yeah, but same as with the Jenkins pipeline, we first push the artifacts to that repository, and then we publish the changes into the config repository to trigger a deployment through Argo CD. That didn't change at all. Right, so that all sounded super nice, and we were just starting to get warmed up. But unfortunately, before we had the change to fully implement that architecture, MoneyBank froze their budget for external consultants. And all we were able to do was to build the POC integration of Jira and Bitbucket before we left. In total, we were with MoneyBank for about 2.5 years, and we transformed them from an organization that went from using Docker Swarm and having applications just running non-virtualized to deploying once every, and they were deploying once every 7 to 14 days to OpenShift and now deploying daily. From what I hear, they kept the general idea of what we suggested, but they made a couple of technical changes. So talk is almost over. I just want to make one more point with this tweet from Kelsey Hightower, where he says, I'm convinced the majority of people managing infrastructure just want a platform as a service. The only requirement, it has to be built by them. So I totally agree. And since I left MoneyBank, I've seen this rise of the internal developer platform, which I think is a great pattern. So this pattern that I just presented to you, I think is kind of a great addition to this move towards like developing platforms internally, because I think the proper evolution for us now is not to like minutely optimize the tools as such, but to see how we can invite non-technical stakeholders into the process of releasing, just to make collaboration smoother and easier, more rewarding, and we can understand each other better. So obligatory, we are hiring Slide. So if you are considering to move to any of these cities, or if you want to work from anywhere on the planet, we are fully remote now. So feel free to reach out to me or also to Dan, because we share we like to share. So yeah, thanks a lot for listening. If you want to reach out to me or learn more about what we do at Container Solutions, all of that's possible. Here's some ways for you to get in touch. And yeah, any questions, comments, happy to have a chat now. Thanks.